Let's look at some symbols used to tell us what's in one atom. These numbers are what we use to know what's in one atom. This top number is called the mass number. It is equal to the number of protons plus neutrons. This bottom number is the atomic number. It is equal to the number of protons. The element symbol depends on the number of protons. So this number down here and the element symbol are actually redundant. With phosphorus as the element, this number down here would have to be 15. We sometimes put it there because it's convenient for another reason. Let's look at our periodic table and where we can find at least one of these numbers. We were just talking about phosphorus. It's right here. And this number above it is the atomic number. So phosphorus always has 15 protons. Another way I could use this, I could say, what element has atoms with 8 protons? So these are in order of atomic number, 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. If an atom has 8 protons, then that atom is oxygen. Okay, here's our next slide. Okay, a definition. Atoms of the same element, in other words, they have the same number of protons, but different numbers of neutrons, are called isotopes. And the word nuclide, you saw that on the previous page, refers to an atom nucleus with numbers of protons and neutrons. When we describe these, or when we use these symbols, we're going to include the whole atom so we can talk about the electrons as well. But a lot of times when you're interested in specifying the isotope type, you're not really interested in the number of electrons because isotopes are important in nuclear chemistry. But anyway, let's see how the nuclide can be specified. So on all of these are all the same nuclide or the same isotope. The 32 in all cases tells you the mass number. So P32, phosphorus 32, and written this way as well, are ways to show that same radioactive isotope it happens to be of phosphorus. Okay, we're switching back to the examples like I write in class. So if you can squeeze this onto your printout, you can, or use your other notes for this. Pause it if you need to catch up. We're going to do some practice problems with using the atomic number and the mass number and the symbols. Okay, so let's look at this one. This is chlorine 37 is how we could say this. This 37 up here is the mass number. It's protons plus neutrons. The number down here, if you look at your periodic table, the number that goes down there is 17. That's the number of protons. Okay, so we got the 17 off the periodic table, the atomic number. So if we use this symbol, the number of protons must be 17. The number of neutrons, to get that, we use, this is protons plus neutrons, this is protons, so essentially we're subtracting those two to see that we have 20 neutrons. And then lastly, electrons would be are the same as protons, when it's a neutral atom. So the way that I know it's neutral is that there's no charge shown, so I'll assume it's neutral, which means that I've got 17 electrons as well. So same example, if I ask the question, what's the atomic number? The atomic number is the number of protons, so it's 17. What's the mass number? Mass number is protons plus neutrons, it's 37. Again, we could write this other ways besides the 37Cl like this. We could put the number after the name or after the symbol. Those are all chlorine 37. Okay, let's go backwards. So we'll start with the number of protons. That tells us the element. So we'll need to look at our periodic table. So looking up on our periodic table, we look for atomic number 16 because that was the number of protons, and 16 that's sulfur. Atomic number 16 we decided was sulfur, so I put an S for my symbol for sulfur, and if I want a number down here it will be 16. That's the number of protons, remember? The number up here needs to be protons plus neutrons. So for that, I'll take 16 and 15. So I need a 31 up there. And then let's see if this one has a charge. To get the charge, that is equal to protons minus electrons, because protons are positive and electrons are negative. So that's 16 minus 17 equals -1. So this one has a -1 charge.